Still within the chapter of miscellaneous TLS topics, we have reached the fourth lesson in our mini-series of 5 covering various significant attacks that occurred on TLS. In this fourth lesson of the mini-series on TLS attacks, we will now look at the crime attack from 2013. The name crime stands for Compression Ratio Information Leak Made Easy and is an attack on TLS connections that compress encapsulated application data before this data is sent to the peer. Compression as a method to reduce the size of data needs to take place before that data is encrypted, as the general principle of compression is to remove redundancy contained in data. The higher the compression ratio on data is, the more redundancy was contained in the data. In the context of TLS, this then allows to steal application layer client secrets, such as, for example, a user ID cookie used within an HTTP GET request. The attacker's aim in this example is to extract the value of the user ID cookie, which in this example is simply the value secret. If the attacker has means to inject paths and queries to the client, then the attacker can repeatedly inject a query for an attribute user ID and repeatedly adjust the value of this user ID attribute and then observe the compression ratio of the TLS packet containing the resulting GET request. The compression ratio in the first example would be low, as only the attribute name and the cookie name overlap in this first GET request. If the attacker then adjusts the value of the user ID attribute from initially A to then read sec, the compression ratio would be higher, as now, besides only the attribute name and the cookie name overlapping, also the attribute value and the cookie value partially overlap, meaning that there is a higher redundancy within the raw application layer HTTP GET request, which compression then can remove for an overall higher compression ratio. By repeatedly adjusting the values of the user ID attribute and observing the compression ratios from the resulting TLS packets, the attacker can then extract the user ID cookie value. Crime can now be prevented by disabling compression within TLS versions 1.2 and lower, or by switching from TLS 1.2 and lower to TLS 1.3, as TLS 1.3 removed compression altogether. So much about crime, an attack on TLS connections using compression to steal application layer client secrets.